This video is about the coefficient of variation. The coefficient of variation is going to describe the standard deviation as a percent in relationship to the mean. It is not considered an official measurement, but it is growing in popularity and being used in statistics as a way to compare data that is not related or don't have similar means when the two data are being compared. The formula to compute a coefficient of variation is the standard deviation divided by the mean times 100%, and that's if that is the sample. And if you're using the population, you just change your symbols, that lowercase sigma over mu times 100%. So the formulas are basically the same, just depends on whether you're using sample population or population. So let's look at a particular example to see how this works together. So we have sample A that has the data 12, 13, 16, 18, 18, and 20. We have data set B that has the data 125, 131, 144, 158, 168, and 193. Of course, by looking at the data, you can see that neither set is anything alike. These, of course, are very small compared to set B. So we know that the means are not going to be anything related. But that's what we're going to go through and find. We're going to find the mean and the standard deviation and the coefficient of variation for each of these data sets. So the mean for set A is going to be 16.17. The standard deviation for set A is 3.13. The coefficient of variation is 19.36%. Because remember, coefficient of variation is a percentage value. For set B, the mean is 153.17. It doesn't matter that it's a population set of data. The standard deviation is 25.29, and the coefficient of variation is 16.51%. Now, let's look at some conclusions that can be drawn. If we were just looking at the means for each of these, or if we were looking at the standard deviations, we would say that set B has a larger dispersion over set A because the standard deviation is larger. So initially, just by looking at the standard deviation, we would make that conclusion. But you'll notice again also the means are very different, and we had already said that the sets of data were very different. But when we look at the coefficient of variation values, we might have a different opinion when we look at them. We'll see that set A has a higher coefficient variation, which really means there is more change within that set of data than there is in set B. So it is important that we use multiple types of measurements to look at data and compare them to make solid conclusions. Sometimes one measurement may not be totally enough. Now, again, some other information that you might want to include knowing about is that when the standard deviation is small, then that means your data is close together. If the standard deviation is large, then that means that your data is more spread out. These are just things that you need to know to help you make some valid conclusions about your data. Another kind of informal rule that you might need to use. We're going to look at this more in our next lesson, but for now, if you take the mean times 2, the mean plus 2 times the standard deviation, or the mean minus 2 times the standard deviation, you will include 95% of all your data. And that means that anything above or below is usually an outlier. Or an extreme value. So that's just kind of an informal rule of determining what something is as an outlier. We've looked at using the IQR as helping us to find outliers. This is just another method of determining outliers. One more informal rule that's called the rule of thumb. Is we can determine a standard deviation is equal to the range divided by 4. So rather than going through that long, complicated calculations that we've been doing, this is just a quick estimate. It's very inaccurate, but it gets us somewhere close to what a standard deviation might be.